All right, so as promised, step-by-step Python autograding in CodeGrade with a special highlight by Sam about the Friendly-Traceback tool. Today, I'd like to go over the steps that you need to take to set up a Python assignment inside CodeGrade, starting, of course, with the design of the Python assignment. Now, most of you probably already have your assignments created, but there are some considerations that you have to make when porting something to CodeGrade or when autograding something in general. And I'm going to go over them. After that, the actual assignment setup in CodeGrade, going over the hands-on requirements, the rubric, and of course, the autograding itself. After that, we'll also briefly cover code quality checking for Python and unit testing for Python, to a little bit more advanced ways of autograding, but very easy inside CodeGrade. Finally, I'd like to briefly go over some more advanced things that you can do with autograding Python. There's, of course, a lot you can do. I'll not show them step by step how you can set them up, but just quickly show you what's possible so you can read more about that in your own time afterwards. And finally, we're finishing with the friendly traceback part by Sam. So let's start with some theory. I'm sorry about that, but we do have to cover some things. So before designing the requirements of your Python assignment, there's a couple of things to keep in mind. Of course, the learning objectives, understanding how CodeGrade can autograde Python code, and how you can set up your assignment in a way to meet both of the above. So, of course, the learning objectives, that's where you as a teacher or an instructor are the expert in. That's not something I'm going to cover in this webinar today, but what I can help you with is the understanding how CodeGrade can autograde Python code and how you can use that to design your assignments in a way to make autograding easier for you. So let's start with some background in CodeGrade Autotest. And for most of you who've used CodeGrade for a longer time, maybe this is already some knowledge you have, but I'll just quickly cover it, so bear with me, please. CodeGrade Autotest is, of course, CodeGrade's autograding system, hence the name, and it runs Ubuntu 18.4.2 at this moment, which is the latest stable version, I think. Basically, it's just a Ubuntu machine in the cloud that you can interact with how you want. So on this Ubuntu machine, there is software pre-installed. For this webinar, Python 2 and Python 3 are pre-installed, including pip and some other libraries of Python, like NumPy, for instance. But if you want to use any other language, things like Java, Git, and other tools and programming languages are also pre-installed there. However, since it's just a Ubuntu machine, you can also interact with it just like you would interact with your own machine using the terminal. Basically, you can install anything on there that you can also install on a regular Ubuntu machine. So you can use bash commands, regular bash commands that you can find endless of tutorials on internet to do things like create folders, move items or files around, install new software using apt-get, for instance, or pip in this case. And you can simply run the Python scripts that you've created using the Python command, which is for Python 2, or Python 3, which is for Python 3. So if you notice, it already gets a little bit easier knowing how you have to interact with this system. Next, inside CodeGrade, we have a couple of tests that you can set up that are easy ways for you to assess code. These tests are I/O tests, which basically are input-output tests. You give the student program a specific input that can be either via standard input. So that is what you would ask for using the input function in Python. So that's something after the program has run that you type in, or arguments, which are the things that the input that you add behind the command. So if you do like Python 3, Fibonacci.py, and then you add your number, then for instance, that is an argument input. And of course, the output. You parse the output and you check if it is what you expected. This is something you do in CodeGrade. And next to that, simple run program tests, simply running a command and checking whether it errors or not. You can do a capture points test, almost the same as a run program test. Instead of it being a pass-fail, you parse the output of the program and that will be the score. Finally, you can use unit tests inside CodeGrade, which we'll cover later, for instance, using Pytest, you can set up code quality tests, which run static code analysis tools like Flake 8 and Pylint that are already installed in CodeGrade, but I'll cover that later as well. And finally, not really a test, but you can add checkpoints to add conditionality within your tests. So these are the tests. And then, as you can see up here, there's two other things here, the global and the per student setup scripts. And those are the places where you configure the system. And I'll go over what they do exactly later on. So today we'll mostly cover the IO test, as these are the easiest tests to test your basic Python assignment. So when autograding basic Python assignments inside CodeGrade and using these IO tests, there's two types of Python programs that are possible to assess. So of course you can use a static Python script where you don't work with input, but all you do is see what the student outputs. In that case, we can use an IO test, kind of abuse it by leaving the input empty to only check if the output is what we expect. And of course, for dynamic Python scripts that use input and output, it is straightforward. You give an input and you check if the output is correct. So now, how do we assess Python code using these IO tests? We have to be able to call the part of the code that you want to assess. This is very important when designing your Python scripts or the assignment that you will give to the student who will create their Python script based on that. If you want to assess the full code, you can run the script with Python 3 and you can give the input and you check the output. But if you want to only assess specific parts of the code, then you would have to either put these parts in specific functions or you have to put the answers that you want to assess in predefined variables. If you have a full script without functions, for instance, and you only want to assess a specific part of that script, it is very hard to just run only a specific part of the script. Of course, it is possible you can create your own custom scripts around it. But if you just want to use CodeGrade for your basic Python assignment, in that case, I would suggest putting the part that you want to grade in a function or asking the student to save the answer to that problem in a predefined variable. In that way, you can use Python's interpreter, for instance, and you can import the student code, and you can simply either call the function or the predefined variable. Today, we'll mostly focus on having a full code with an input statement. But just know that if you want to assess parts of the code, you have to put it either in a function or a predefined variable. So now that we're designing a Python assignment, let's see how that looks in practice. And for today, I would like to go over two example tasks that we can give to students. These are a Fibonacci assignment and a calculator assignment. Most of the webinar will cover the Fibonacci assignment. The calculator assignment is mostly for the unit testing part. So let's see what makes them easy to autograde and how do we autograde them. And for that, let me quickly switch my screen to something else here. Give me 1 second. All right, new share. Perfect. Can everyone see my code now? Am I sharing the code? Yes, great. So let's see what makes these easy to autograde. We have the Fibonacci.py, where we ask the students to run the script and given an input, output that number of the Fibonacci sequence. And in this case, we have a full script that we want to assess. We don't want to assess specific parts of the script. We just want to assess the script as a whole, which is possible since we don't use functions. We don't use specific variables that we told the students to. So we can only assess this one as a whole. We ask for input using Python's input, which we can use an IO test for to give this input. And then we print the output so that we can parse this in the IO test and compare with our expected output. So this is one that is very easy to autograde. Now, for the calculator right here, we can also autograde this, but because we are using functions, we can also autograde specific parts of this assignment, which is something that's not possible here. We cannot say, for instance, that we only assess the input part or only assess this part, because they're not as separate functions, so you cannot call them separately. In this case, we can separately call the add, subtract, multiply, divide functions and see if they work. That's also exactly what we're going to do later on using the unit test. So let me switch back to my slides. There we go. Great. So let's start, as I mentioned, with the Fibonacci assignment. So the student, as a learning goal, learns how to use loops. And the objective is, given input n, print out the n numbers of the Fibonacci sequence. So if they print out 3, the student prints out 0, 1, and 1. Yeah, 1 and 1. Yes, I know Fibonacci. So let's start setting this up inside CodeGrade. Essential tools for any basic Python assignment in CodeGrade are, first of all, the basic assignment settings, then the handle requirements, submission settings, rubric, very important, and the autograding, which we'll do in the next step. For now, we'll set up the basic assignment without autograding. So we already did a webinar earlier on about rubric design, specifically for rubrics for computer science. So I really recommend watching that so you can learn more about how to design a meaningful rubric. I'll not cover that today. So let's go and set this up. I have the assignment right here, just an empty CodeGrade assignment that I just created called Python Fibonacci. And let's set this up. Let's set up the basics of this assignment. So first of all, the assignment name, the assignment state, or the assignment deadline, and available at. These are settings that you normally set in your learning management system. So I'll not cover them right now. What I will cover, though, are the submission settings. So by default, students can only upload using the file uploader, but they are also allowed, or it's also an option in CodeGrade to allow them to upload via GitHub and GitLab. For most introductory courses, I would highly recommend not using that, since for students to learn how to code is already a big step, and then also learning Git right away is another huge leap for them. So for introductory courses, I always recommend just using the file uploader. But once you are getting more advanced, you can allow the students to also use GitLab or GitHub and turn on both, so they can choose what they will use. Or if one of your learning goals of your assignment is to use Git in the course, then you can turn off the file uploader and the students can only submit via GitHub and GitLab. Next to that, by default, students can submit as many assignments or as many submissions as they want, as many attempts as they want, and they don't have any waiting time after a submission. For introductory courses, again, I recommend leaving it this way, as this feedback loop is very valuable to the students. However, if you have more advanced assignments or you want to meet certain learning goals that you have for your assignment, it can be an option to minimize the maximum total submission. For instance, you can say that they only have 3 attempts, or you want them to wait, let's say 30 minutes after every attempt, so they cannot brute force the system, but instead they're forced to think about their assignment 30 minutes after every time they upload. For this assignment, though, I'll leave this at the default, which is fine for a basic assignment. So if you scroll down here, you can find the other options here. The other option that I want to cover right now are the hand-in requirements, which are, in my opinion, an essential part of most assignments inside CodeGrade. With the hand-in requirements, you can tell the student exactly what they are allowed to hand in and what they are not allowed to hand in. So in this case, we have the Fibonacci assignment. Let me go back here, where we ask them to create a Fibonacci.py. So in this case, I only want them to upload a file called Fibonacci.py. So let me create the hand-in requirements in a way that I deny all files, and I tell them to hand in a Fibonacci.py. Save. So as you see, I started with a / here, which means that I want them to upload this Fibonacci.py in the root directory of their submission. Since they are allowed to hand in zip folders or archives as well, having this in place make sure that they don't have folders leading up to this Fibonacci.py. However, since I have delete leading directories enabled right here, they are deleted automatically right away. So let's submit this. And now the student is only allowed to hand in a file Fibonacci.py. And this is important, you'll see later on, when we are going to be auto-grading, that we know for a fact that the student calls their file Fibonacci.py, and we can actually start grading that. So let's skip the graders and the plagiarism tabs for now, and we can continue to the rubric tab right here. So let's create a new rubric and create two categories in this rubric. So the first category will be the automatically graded category, which is a continuous category where the student can score between your minimum points to your maximum points, and they can score anywhere on that scale. I recommend using these continuous categories for automatic grading, as it maps very conveniently with any number of tests that you define inside your auto test. So let's set up this test. Let's see functionality of description. And as you can see, I'm using Markdown in here. That's possible also. So we have this as a code snippet right here. And they can score anywhere between 0 and let's say 8 points. Next to that, just for educational purposes for you guys, it's not really needed for such a simple assignment as this one. Let me also create a discrete rubric category that will manually assess, which we call a manual check. And with a discrete category, this is your traditional rubric. You can make a couple of items and the student can score by you clicking one of these items. So let's start with 0, 4, 1. So please use better names here. And I talk all about these names in the webinar on rubric design and feedback. But for now, this is sufficient. Great. So now that we press submit, we have saved the rubric and we've set up the general settings of the assignment, and we can start creating our auto test. So let me go on there. To start off, let me give you a quick example or a quick background on how auto test works. We already mentioned it a bit in the beginning. So before you start an auto test, it will spin up a server on our cloud infrastructure, and this will create your testing environment. And first, it will run your global setup script, in which you can install the software that you need. You can upload things to auto test as well. They're called fixtures, and it will configure the whole environment. This will also be cached, so this will only be to run one time, and then after that, every time a student submits, this will be cached and it will not install the software again. Especially if your software is a little bit bigger, or if it's performance heavy install step, then this takes a lot of time away of the students. So after that, as soon as a student hands in, it will spin up a new server from this cached environment, and it will load the student code on this server in the student directory, which in Autotest is also the current directory. After that, it will run your per student setup script. Let's say you want to compile things, which is not needed for Python, but for instance, for your Java assignments, that is something you can do in your per student setup script. After that, it will just go through all your tests that you've set up, and each category again will start clean from a new step after the per student setup script. So the categories are all parallel with each other, and they cannot interfere with each other. All of them start clean again. Great. So for Python autograding, for most assignments, luckily there's no setup needed. So no global setup script or no student setup script. All software that you need are already pre-installed in CodeGrade Autotest. The submitted code is in the current directory, also refers to the student directory, and all the tests that you set up have to be linked to rubric categories. So here is why the assignment setup is so important. First of all, the code that the student submitted is in the student directory. But since we use these hand-in instructions, we know that this will always be a file called Fibonacci.py. So we always know that for this assignment, if a student has a successful submission, it is in the student folder and it is called Fibonacci.py. Now, here is where the rubric design comes in. All the tests that you set up in Autotest have to be linked to a rubric category to automatically fill in that category, which is way better for the student, as it's very clear to them what these tests actually grade. So that's why designing a good rubric is an important step before you can actually start setting up your autograding. Great, so let's set up our IO test for our Fibonacci.py. And we can go to the auto test step right here. We can create an auto test. And as I mentioned, we don't have to upload anything. We don't have to install anything here, and we don't have to install anything here. Again, going back, if you want to install anything, you can just simply type in bash commands here and here. You can already see some of the bash commands that I previously ran here. So this is simply bash that you use to interact with the terminal. Great. So let's create a level and let's create a category in that. Select the rubric category that we want to fill in with these tests. So of course, we created this functionality of your script rubric category that we wanted to fill in. And now we can simply create our input-output tests. So now the fun starts, and it's really easy. So let's call this functionality check. And the program to test basically is the bash command that you want to execute to test the program. So every time for every input and output pair, this will be run. In our case, of course, we use Python 3, which is pre-installed, and we can find the Fibonacci.py file. So as I mentioned, the student folder is the current directory. With the hand requirements, we told the student to upload Fibonacci.py, so we know that it's here, and we can simply access it. Now, we can start to create our input and output pairs. So let's start with an input pair where we give an input, let's say 3. So we expect 3 numbers of the Fibonacci sequence to be the output. So that will be 0, 1, and 1. We can give this input and output pair a name. So let's call it short. And if we want, we can set up some options here. So by default, this case is sensitive. We ignore trading white space. In this case, let's ignore white space. As we just want to check if this is the output or not. And we can make it a substring match. In this case, let's turn off substring match, as if they output this, for instance, then this part is still substring of that. So that should not be a valid answer. So let's turn off substring match. So only if this is the sole output, it is correct. Great. So let's move on here. We can create another input and output pair, and let's call this a long sequence and ask for 15. No, let's do 10, because otherwise you will see how bad I am at math. 2, 3, 5, 8, 13. How many are we? 1, 2, 3, 4, 5, 6. 7, 8. All right. 1, 3, 4. Is that correct? Should be. All right. Great. So, great. So this is the output that we expect, and we've now created 2 tests where we check for the input. Given an input, we check if the output is correct. And of course, we use this input right here, as in the script, as I showed you before. We use Python's input statement to ask for standard input. If you would want something to be added or appended to this command, let's say we want to give our input as input argument, we can put this tree right here, and it will be appended to the command. Great. So now that we've set this up, yes.
Can I interrupt you for a second?
Please.
Anders asked a question in the chat. He asked, what do you mean when you're saying check for valid inputs? I think you were talking about whether the script checks whether it's a valid input. Is that right?
Yeah, you check for negative numbers and so on in your script.
Yes, yes, very good. Yes, so as this is just the basic assignment, the auto-grading assignment, I'm not going to go over input validation. But let's say it's a part of your assignment. Of course, you can also do input validation, where you check if the student inputs something like a word or a negative number, that they show they catch that, and they show that, or they give a helpful message to you. And you can also check that using an input-output statement. So let's call this invalid input, and let's say we give this a word. And then let me check what the output is that we asked them to give. This is what they should write. Please input a positive number. So in that way, and let's turn on substrate for this, we can also check if they use input validation. Yes, good question. And I'm very happy that you didn't mention that I messed up something here. That was what I was scared of when you interrupted me, Sam. All right, so let's save this and run this, start it up. Yes, so now it is started up. And now from this moment, every time a student uploads, they'll get instant feedback from this auto test, as we have make results visible to students immediately turned on. So to test this, I would recommend making a test submission. We can do that by going to the general tab and uploading a test submission here. So let me upload Fibonacci.py. Oops. Let's drop it. Yes, submit. And now if we go back to the auto test tab, we can see that we have a test student, so a test submission right here. And within a few seconds, we'll see that this is started up, and we will get our output, and we can see if what we've created is correct. So I would really recommend that you always do this before actually opening your assignment to your students, as it is important to check and confirm that you didn't make any small mistakes in your auto tests. Even for these small assignments, I sometimes mess up as well. I'll be even surprised if I didn't make a mistake.
May I ask a question?
Yes, please.
So now it took 15 seconds to this virtual machine running, and in the beginning you mentioned that it's going to be faster. Did you mention this time? This is the time that is going to be faster.
Yes.
Right.
Yes.
Very good.
Good question. Yes. Wonderfully, I didn't mess up anything, and we see that it all passes. So the input that we give is 3. The expected output was 1 or 011, and the actual output was also 011. Same goes here. I'm very surprised by myself. This is also what we expect. So great. Even the invalid input, where we input a word, a number, or another number, the output is as expected. So you can also imagine you can add as many tests here as you want. And since we use a continuous rubric category, these tests will just map on the scale that you've set up there. So great. This is already your basic IO test in your basic Python assignment. We can now add a code quality check to this. And to give you a little bit of background on that, with CodeGrade's code quality check, you will run a static code analysis tool, and you can check for things like style errors, for instance, whether the student follows a certain style guide that you told them to. You can check for documentation, common code mistakes, inefficient or dead code, bad programming habits, and duplicate code. That's not plagiarism, but duplicate code within the file. So let's say it's something called dry, don't repeat yourself. And if they do repeat yourself, then some of these tools can tell the students that they're repeating themselves, which is a bad programming habit. So for Python, one of the most common style guides is the PEP8 style guide, which stands for Python Enhancement Proposal. And I guess it's number 8. It improves the readability of code, and why it is important is stressed also by Python's founder, Guido van Rossum, who, by the way, is also from Amsterdam, where CodeGrade is based. A quote of his is, "Code is read much more often than it is written," and I think that is very true. You write your code once or in a short period, but the years leading up to that, you will be maintaining your code, others will be maintaining your code. So code readability is something that's very important to be taught to students very early on. Also, learning to work with a style guide is especially important for computer science students who probably in their later career will work together in big groups working on software. So within CodeGrade, a code quality check can assess the style or readability of code, and it will give comments right away in the code. So that looks very intuitive to the student. The line that it checks will be highlighted in red, for instance, and they can hover over and see which error there is. Of course, within Autotest, they can also see an overview of all the errors, but seeing it in the code is most intuitive for them. So for instance, here we have the imported but unused error from Flake 8, which is part of PEP 8 as well. So let's set this up inside our Fibonacci assignment. Luckily, that's very easy. So let's stop the Autotest so we can start editing it. And if we scroll down, in this case, let me just add it to this rubric category. Now we add a code quality step right here. And let's give the name. Follow 8 rules. And we can select the linter that we want to use, static code analysis tool. For Python, the two linters that we have set up are Flake 8 and Pylint. Flake 8 is the most basic tool of the both, which is very easy for you because it needs no setup, no configuration. Pylint offers a little bit more flexibility, but does need configuration. So that is a trade-off that you can make. For now, for the purpose of this video, I will show Flake 8. And we don't have to set up anything else. We can just leave it like this. And we can save this and start it up. And we can see if this student, which is me, made a style mistake. Which I did on purpose, by the way. I'm not a bad programmer. Just wanted to mention that.
Technically, I made the mistake because I wrote the program.
All right. Let's see if this is going to run. Why is it not starting up? That is strange. Oh, there we go. Should run in a second. And we can see that it has a partial score, and we can see that there is an import that is unused. If we click on here, we will be taken right away to their code, and we can see here that there is an import statement that is unused. And hovering over will also give us this error. Of course, this is a very basic error, but you can imagine that you can use this for other purposes as well. So continuing on, if you want to ignore specific rules, or use any other command line interface options from Flake 8, you can do that in the extra arguments here. For instance, if we want to ignore rule F401, you can find a list, by the way, of all these rules on Flake 8's documentation. You can give this command and it will ignore it. Same goes for other tools like Pylint. You can provide a configuration file which will include and exclude the rules exactly how you want to. All right, so let's go over unit testing right now. And for this one, we will be using not the Fibonacci assignment, as there's no functions in there, so there's no functions to unit test. We'll use the calculator.py, which has these functions. The student is asked to create 4 functions: add, subtract, divide, and multiply, which mimic, of course, adding, subtracting, dividing, and multiplying. And the objective of this assignment is be able to call a function which returns the arithmetic result that we expect. So if we call the divide function, we expect x to be divided by y and that to be returned. So since we've already done the assignment setup, for this, I will just show you how to set up the Pytest unit test. So Pytest is one of Python's most popular unit testing frameworks. And often within, of course, unit testing, a unit is a function within Python that we test individually. Pytest is also pre-installed inside CodeGrade and built in, and it's ready and very easy to use. So to use Pytest in CodeGrade, there's 2 steps. First, you have to upload your unit test script as a fixture, and then you have to create the unit test step inside CodeGrade and run it with the script that you've uploaded. Designing a unit testing script is not in the scope of this webinar, but I will show you how easy that is, as I will show you the example unit test script that we use now. So first of all, uploading your unit testing script as a fixture, very easy. Let me go to the assignment that I've set up for this. If I go to the assignment settings, as you can see, this assignment already has a rubric set up. And if I go to auto test, I can create the auto test. And where we didn't have any setup in the previous assignment, for this one, we will upload a fixture. Let me quickly drag and drop it, submit it. And now this fixture is available on the Ubuntu machine in Autotest. So every time a student uploads something, this fixture will also live in that environment, but not in the student folder, but in the $ fixtures folder. Great. So now we can actually create the Pytest unit test step with our script. That is also very easy. So we can add a level, and within a level category again, we select the rubric category again that we want to fill in. Again, this is the functionality. And we now select the unit testing step here. Unit testing. So select the framework. As you can see, there's a big list of frameworks that are pre-installed and built into CodeGrade. These will all run out of the box. All you need to do is, as I show you right now, upload the unit testing script and run it. You also have the option to use your own custom unit testing frameworks if you want to use anything else. So let's select Pytest here, and the file to test is our unit testing script. So that's in the fixtures folder, and it's called test calculator.py. Great, we don't have to set up anything else here. This will work now, but we can of course give extra Pytest arguments if we want to. So let's save this. And just to show you how simple this unit testing script is, as you can see right here, we import Pytest and we import the calculator. And after that, we just assert whether the calculator works. So we call the function and we check if the answer is what we expect it to be. And we have a couple of them per test. So actually, we followed this tutorial. Maybe Sam, you can post this in the chat, or I can do it later on, which I think is a very good tutorial, right, Sam? On how you can set up unit testing for Python using Pytest.
Indeed.
So if you're not familiar with that,
that's exactly how I figured out how to write this unit test. I was a beginner with Python at that moment, so it's a very handy little thing. I'll post it in the chat in a second.
Great. Thanks, Sam. So I'm starting this up, and we will run the unit test, and we will see what this looks like now inside CodeGrade. Oh, by the way, I already uploaded the calculator.py file, of course, as a test submission right now, to make this all a little bit quicker for you. So let's see. So the reason why this is now taking a little bit longer is that it's uploading the fixture. So we do have a little bit of setup now, but that is, of course, cached. And that waiting time will not be there for students who use the cached environment after you've ran it for the first time. Great, so now it's running. And if I didn't make any mistakes, this should now show us, yes, great. So it will expand the different tests and show where it went wrong. So this is on purpose, of course. Sam is also a good programmer. Yes,
Devin, can I interrupt you for a second?
please.
Anders asked if we can show the setup contents.
Can you elaborate on that, Anders?
Yes, the setup drop-down menu. If you scroll up.
Oh, you mean right here?
Yeah.
Yes.
There are very good logs there if something happens.
Yes. Yes, I understand what you mean. So maybe a little bit more advanced than the scope of this webinar. But if you use one of these unit test frameworks, the unit test framework will automatically be installed inside CodeGrade. And that will be automatically added to your global setup script. You don't have to do anything for this. This is all automatic. But let's say there is an error in your unit testing framework. You can always check the setup tab up here, and you can see if there were any errors in here. So you can check the standard error button, and there will be a standard error button here if there's any output as well. Yes, very good addition. Thank you, Anders. Great. So to continue on, of course, we chose the Pytest, I'll show you that, and the output looks like this. Great. So some more advanced things that you can do with this, and I'll go through this really quickly since it's already getting late. So your Pytest tests, you can also change the names and the weights of them. So by default, all of them have a weight of 1. All of them have a equal weight. And the tests are the name of the function that you defined in your Pytest testing script. What you can do, though, is use the record XML attribute that you can use, and you can use that to change the XML attributes name and weight, which are parsed in CodeGrade to change, well, the name and the weight of the unit test step. So what it looks like is this. In your unit test test function, you can have the record XML attribute function, call that with a name, and then after that, you can change the name to something else. Same goes for this one, where we are also changing the weight, which is a separate XML attribute. In this case, we're making the weight 2. And in CodeGrade, that looks like this. The name will be changed, so there will be a custom name next to it, and they show the weight. So in this case, all of them have a weight of 1, except for this one that has a weight of 2. When we post the recording on our blog, we'll also post this picture, so it's a little bit easier for you to look at this. I think we've already had this picture in some of our previous blogs as well. So finally, something I wanted to share very briefly is Semgrep, and I've been setting up a lot of introductory Python assignments recently, and I've noticed that also for them, Semgrep is a really useful tool. With Semgrep, you can check the structure of a student's code very easily. And for instance, if your learning goal for one of your introductory assignments is that your students use a for loop or a very specific Python function, you can detect if they actually use that. And you can give them feedback on the fact if they use it or not. Which, especially for these introductory Python assignments that you may want to fully autograde, is very useful. It's very easy to set up, and we have a blog post on how you can set this up. If there is enough demand, I am thinking of doing a full webinar just on Semgrep sometime in the future, as I think it is a very useful tool. So this is already pre-installed on CodeGrade as well. It's part of the unit test step. And you can learn more about this in our previous blogs and webinars. We've mentioned it a couple of times. This is definitely something that's very useful also for introductory courses. All right.
Lots of people saying that they're really interested to get a Semgrep webinar.
Great. Well, that solves a brainstorm for the next webinar already. Great. So without further ado, well, we are running short on time, but I'm sure that it doesn't matter. We are 5 minutes over time. Otherwise, if you have to leave, of course, with recording, and it will be up on Monday next week. So Sam, please take it away. Thank you for taking this over from Andre.
Of course. Very happy to be joining today for, showing you Friendly. So recently we came across Friendly and we thought it was a really, really cool tool. So we wrote a little blog post about it to explain how you can use it in CodeGrade. Devin, maybe you can add the link to the blog post in the chat. And of course, you can follow this webinar to learn how to install CodeGrade, install Friendly in CodeGrade. But yeah, basically, what is Friendly? Friendly is an external module, and it extends Python's traceback. So the idea is that Python produces an error traceback if your program errors out. And with Friendly, it expands on that to make it more readable for beginners and hopefully more friendly so that they're able to solve the error in their code. We were hoping that we'd be able to get the creator of Friendly speaking today, but unfortunately he wasn't able to make it. So I'm just going to quickly walk through how Friendly looks and how it works. And why it's a good idea to maybe try it out for your Python classes in CodeGrade. So let's keep going. So just to give you a little example of how Friendly works, this is a little code that I wrote, and it's got a clear and obvious error. The problem is that we have a list with 3 numbers in it, 1, 2, and 3. And we take the length of that list and pass it back as an index of the list. So the problem is that the list has a length of 3, but the last index of the list is 2. So Python will then give us an index error when we try to run this program. Next, please. Thanks. So traditional Python traceback would look a little something like this. So at the bottom line, you can see that it's giving us an index error, and it just gives a little explanation of that, saying the list index is out of range. As a experienced Python programmer, you might understand, oh, I know exactly what an index error is, and then I can read through the traceback or the stack trace to see which line of code I indexed my lists incorrectly. But for a beginner programmer, that might not be so intuitive. That might not be so obvious. So Friendly is a module that you can use to extend the Python traceback. And it gives you a bit of a longer traceback, but it does provide a lot of additional context and a lot of additional information about what caused the error in your program. So some of the things that Friendly-Traceback helps to make clear about the error. So one thing it does is it provides a reminder that Python uses 0 indexing. That means that indexes start from 0. So a list of with 3 places will have a max index of 2. It explains what Python's index error is. It gives an overview of the variables and the values inside of the student's code that created the error. For instance, here it says that sequence has a length of 3, but you've tried to index it. It has a max index of 2, but you've tried to index it with 3. So that's just not possible. And then it also elaborates on where the program exits, or what was the last line of code run, and then where the exception was raised in the code. So as you can see, it's a lot clearer, and there's a lot more context behind what creates the error in your program. So can we continue?
Yes.
I wrote another blog post before we found out about Friendly, which actually really gives you a good idea of why Friendly could be a handy tool to incorporate in your CodeGrade assignments, particularly for beginner Python programmers. Because giving content and situation-specific feedback really boosts learning outcomes in students. A lot of recent research has shown that when students are able to get feedback while they're programming, and that they're able to then apply that feedback to their code, they're able to learn much better than if, for instance, they would get their feedback once they had already submitted their assignment and their assignments were already graded. So the idea is that they're learning through this iterative feedback process, which CodeGrade enables to do, with the added benefit of having this very content-specific feedback. So also on top of that, students are able to learn from the mistakes that they make on the go. And because Friendly's feedback extension gives you a lot more information about how Python really is designed and how it works, and things such as list indexing, zero indexing, value errors, data types, those kinds of things. Students really get a much better idea of how common programming misconceptions can be avoided in the future. So it really helps them to learn what mistakes they're making along the way and hopefully prevent them from making those mistakes again in the future. And with that being said, I'm going to quickly share my screen and show you how Friendly looks inside CodeGrade.
Sam, I think
the
time-wise, maybe we have to skip this part. That's
okay. Yeah, sure.
Yeah.
No worries.
Awesome. Yeah. Thank you so much. We had to improvise today, and thank you very much, Sam, for taking over this part, since you created the blog also about Friendly. So, as he said, very useful tool, especially for introductory Python assignments and courses. And if you want to use it, we'd love to help you out how to set it up. You can also see Sam's blog that he wrote about it, which I put in the chat. A quick summary of that. So what you can do is you can create a small bash script called Friendly, which installs Friendly using pip. And after that, make sure that Friendly is run by default. And you can save this as a fixture and then run it in your global setup script. So it will set up the environment for using Friendly. And now our output will be automatically Friendly-fied by default. So very great, very useful. And that's why we could skip it, since I have a picture of what it looks like inside CodeGrade right here. So thank you so much, Sam. And thank everyone else for sticking with us. Sorry, we were 3 minutes over time. Hopefully this doesn't mess up your schedule too much. Thank you very much for joining today. And after the recording ended, we will have a Q&A where you can ask your questions if you have any. And I'm looking forward again to seeing you in next month's webinar, which you will be invited to shortly. All right, thank you.